All right, so now we're looking at the 2x2 matrices, which is associated with rotation. And ladies and gentlemen, why are we doing this? You have a very uncertain exam that is coming up. Nobody knows. You have never had an exam of this type. So we need to go in there as prepared as possible. All right. And these are easy questions that an examiner could ask in a multiple choice. All right. First of all, RO, as we were discussing earlier, RO plus 90 degrees is an anti-clockwise rotation of 90 degrees about the origin. Now, in an anti-clockwise rotation of 90 degrees about the origin, the X and Y coordinates interchange and the sign of the new X coordinate change. So in an anti-clockwise rotation of 90 degrees about the origin, the X and Y coordinates interchange and the sign of the new X coordinate changes. Ladies and gentlemen, this is the interchange matrix. And if I put a negative at the top here, that's what both what interchanges and change the sign of the new X coordinate. Now, in a 180 degree rotation about the origin, the signs of the coordinates change. That's all happens. So 1, 1 will become minus 1, 1, 2 will become minus 1, minus 2. The X and Y coordinates interchange. Now, this is RO 180. All right. Now, notice that this 180 is neither positive or negative, because if you rotate 180 degrees to the right and 180 degrees to the left, it will carry to the same spot. All right. Now, this is the I matrix, 1, 0, 0, 1. It does nothing to a point. But if I do this, that changes the sign of the X coordinate. And if I do that, that changes the sign of the Y coordinate. So the 2x2 matrix that is associated with a 180 degree rotation about the origin is minus 1, 0, 0, minus 1. Finally, RO positive 270. Now this is an anti-clockwise rotation of 270 degrees about the origin. Now in a 270 degree rotation, in an anti-clockwise rotation of 270 degrees about the origin, the X and Y coordinates interchange and the sign of the new Y coordinate changes. This is the interchange matrix. And if I put a negative 1 down here, this matrix will both interchange and change the sign of the new Y coordinate. These are the three matrices which are associated with rotation, with 90 degree rotation, 180 degree rotation, and a 270 degree rotation about the origin. All right, let's pause here because I want to see if you guys could, based on your knowledge of what happens in these different types of rotation, if you could come up with the matrices on your own. So now we're going to look at a composite transformation. As I said, bear with me, it is a new mathematics topic. You have never done it before, and it is the first I'm teaching this topic at Stats. The first. In the 5 years I've been here, I've not taught it. And that is as a result of the fact that we have not been able to finish the syllabus. We have not gone this far in the syllabus. One of the reasons why we are this far is because COVID gave us the opportunity. All right, so let's have a look at a composite function. And then we're going to have a look at an example. This says the composite transformation, it says composite transformation. The composite transformation P is equal to Mn consists of a transformation N followed by a transformation M. So what this is saying is that a composite transformation is a combination of transformations. So for example, somebody could say, reflect something in the x-axis and then reflect it in the y-axis. That is what you call a composite transformation. Now, there is a matrix associated with each transformation, but by multiplying these two matrices, you can get one matrix that does the job of the two matrices. To get that one matrix, what you're going to do is that you're going to multiply the two matrices. When you multiply the two matrices, you're going to put the second one first and the first one last. So the composite transformation P is equal to Mn consists of a transformation N followed by a transformation M. So the first shall be the last and the last shall be the first. Let us try and see this in action. All right. I think I'm going to pause. I want you to write the notes, so I'm going to pause. All right. So example 4. All right, and this is coming under composite transformation. We said earlier that the composite transformation P is equal to M multiplied by N, consists of the transformation N followed by a transformation M. So you can obtain a composite transformation by multiplying the two transformations. But when you do that, you must multiply the first transformation. Sorry, you must switch them around. The first will be the last and the last shall be the first. Let's have a look at example 4 quickly. So example 4 says Q is the transformation represented by the matrix 0, -1, -1, 0. All right, so I'm searching my mind now to try and remember which transformation that is. All right, and I think I have it down. All right, it says R is the transformation represented by the matrix 1, 0, 0, -1. All right, I think I know what that one is as well. So we're asked to describe the transformation represented by Q and R. So Q is the matrix 0, -1, -1, 0. All right, and I think this is M, Y is equal to -X. Am I correct? I think when you reflect in the line Y is equal to -X, the X and Y coordinates interchange and their signs change. So Q is, which is a reflection in the line Y is equal to -X. All right, now R, which is the matrix 1, 0, 0, -1. This I think is a reflection in the x-axis because it changes the sign of the y coordinate. So this is M, X, which is a reflection in the x-axis. All right. So that's the first thing. Q, with Q, that interchanges the x and y coordinate, and it changes their sign. So the transformation that does that is reflection in the line y is equal to x. R, in R, all R does is changes the sign of the y coordinate. The transformation that does that is reflection in the x-axis. So next, we're asked to what? Determine the single matrix L, which represents transformation R followed by Q. Now, to determine the matrix L, what we're going to do is that we're going to multiply R and Q together. But we must put the Q first and the R second, because the first shall be last and the last shall be first. So to the next page, the matrix L would be equal to QR. So it's R followed by Q. So when you're multiplying it, the one that you do first must go last, and the one that you do last must come first. So let's multiply these two matrices. Q first, 0, -1, -1, 0. And then 1, 0, 0, -1. When we multiply two matrices, we multiply the rows of the first matrix by the columns in the second matrix. So I'm going to multiply the top row by the left column. So it's 0 times 1, which is 0, and -1 times 0, which is still 0. So let's do that again. So I'm going to multiply the first column in the row, which is 0. Sorry, the first element in the row, which is 0, by the first element in the column, which is 1. So 0 times 1 is 0. And then the second element in the row, which is -1, by the second element in the column, which is 0. So -1 times 0 is still 0. I just multiply the top row by the left column. Now I'm going to multiply the top row by the right column. 0 times 0 is 0. And -1 times -1 is +1. Now I'm going to go down to the bottom row left column. -1 times 1 is -1. 0 times 0 is 0. Bottom row right column, -1 times 0 is 0. And 0 times -1 is also 0. So the matrix that results is, or the matrix L is the matrix 0, 1, -1, 0. All right. So that is the matrix L. How do we get the matrix L? We get the matrix L by multiplying Q and R. L is a composite transformation, which is R followed by Q. To get the matrix that represents this composite transformation, you must put the what? The first transformation last and the last transformation first when you are multiplying them. All right. The third part says, calculate the coordinates of the image of the point P of the point -1, -1, 3 under L. So this is L. L is 0, 1, -1, 0. And we're applying it to the point what? So this is L. We're applying it to the point -1, 3. Can somebody tell me what will happen to the point when I apply this matrix to it? Anybody? Can somebody tell me what will happen to the point? Now, first of all, you don't have to know, you could just simply what? Multiply them and get the answer. But can anybody tell me what will happen to this point when L is applied to it? Anybody want to try? If you apply L to this point, it's going to interchange the X and Y coordinates. They're going to switch around. And the coordinates of the new Y coordinates, the coordinates of the new point Y will be changed. So the new Y coordinate will be changed. The sign of the new Y coordinate will be changed. So I bet you that the answer is going to be 3, positive 1. But let's multiply it and see. 0 times minus 1 is 0. And 1 times 3 is 3. Minus 1 times minus 1 is 1. 0 times 3 is 0. The answer is 3, 1. So the point minus 1, 3 under the matrix L becomes the point 3, positive 1. So the point minus 1, 3 under the transformation L becomes the point 3, 1. What else? Now this says to determine L inverse. All right, can anybody describe L for me? Well, what I did here is that I just wrote down L inverse. For me, looking at it, L look as if it is a reflection. L look as if it is a anticlockwise rotation of 270 degrees about the origin. So I don't know if this is correct for L inverse though. Because, all right, let's erase this. L inverse, I'm erasing this. I don't think it's correct. I'm erasing this. All right, so L inverse. We already have L. L is 0, 1, minus 1, 0. 0, 1, minus 1, 0. That's L. Let's ensure we did it properly. QR. L is QR. So it's Q and we multiply it by R, fine. L inverse, this is L. L inverse is 1 over the determinant of L times adjoint L. The determinant of L is 0 times 0, 0 times 0, minus 1 times minus 1. So this is 0 plus 1. The determinant is 1. So L inverse would be 1 over 1 adjoint L. You want to switch these around. So this is 0, 0. The other two stay where they are, but their signs change to minus 1, 1. And so L inverse is the matrix 0, minus 1, 1, 0. All right, that's L inverse. So if you needed to do that, that's what you needed to do. It's simply just finding what? The matrix inverse, which is something that you know how to do. L inverse is equal to 1 over the determinant of L times adjoint L. The final part of the question, this says, use L inverse to calculate the coordinates of the point whose image under L is minus 5, 2. So in other words, this is what this is saying. You had a point which is what? X, Y. You don't know what it is. X, Y. And L is applied to it and it became minus 5, 2. Watch me. You see if L took XY to minus 5, 2, L prime will take what? Minus 5, 2 back to XY. So to find out what xy is, I have to multiply L prime, which is 0, minus 1, 1, 0, multiply by this point, which is what? Minus 5, 2. Listen, this is L prime. So if L took it to minus 5, 2, L prime will take it back. So I just simply multiply L prime by the point to get back what was the original coordinate. This is the image. And when I apply L prime to the image, I will get back the object. So if I apply this, I'm going to get what? They're going to interchange. So 2 is going to come to the top. And the sign of the new x coordinate, which is 2, is going to change. And the y is going to go down to the bottom. This should be the answer. If you didn't know that, you could simply work it out. 0 times minus 5 is 0. Minus 1 times 2 is minus 2. 1 times minus 5 is minus 5. 0 times 2 is 0. So the point, this point now, under L prime, will become minus 2, minus 5. So this would be the object. So in other words, L will take minus 2, minus 5 to minus 5, 2, and L prime will take it back. So the original point was minus 2, minus 5. The original point was minus 2,